So yesterday we looked at graphing trig equations, and today we're going to look at solving trig equations. So what, if you recall from yesterday, is important about a trigonometric function is that it is cyclical and that the cycles repeat. And so a trig equation is going to contain a trig function that is true for only certain values of the variable. But because technically there is no restriction on the range, unless we set one, that value can occur over and over and over again. So we're going to look at how, when given a specific domain, how we can solve for a trig equation. So if we look at this example of 2 cos theta minus 1 equals 0, we're actually going to look for a specific value of theta that would make that equation true. So as with solving any equation, the first thing you need to do is isolate the variable. And so in this case, cos theta is going to equal a half. So you need to now think about your special triangles, and just if you remember, that 1/2 comes out of the special triangle of the 30, 60, 90. Because remember, this comes from the equilateral triangle, where the base angle is 60, the top angle is 30. And so on our unit circle, cos theta is x over r. So when x is a half and r is 1, theta is equal to 60. So therefore, cos theta is going to equal a half when theta equals 60. Now, remembering that this is a repeating pattern and that the related angle of 60 is going to appear 4 times in the unit circle. But what is important is that we have to only look now for when the related angle is positive 60 or is going to give you a ratio of positive a half, because theta is equal to positive a half, not negative a half. So we'll normally give you a restriction, like between 0 degrees and 360, or between negative 360 and positive 360. So over the last couple of days, we've been looking at the unit circle, we've been looking at our graphs, we've been creating our graphs, we've been looking at what the related angle is, and how when that related angle is in different quadrants, sometimes cosine is negative, sometimes it's positive, same with sine and same with tan. And so what I'm going to do now is give you a rule. It's called the cast rule. And this is where, depending on the quadrant, that is where that particular trigonometric ratio is going to be positive. So the cast rule actually starts in the 4th quadrant, and then it goes counterclockwise. So if you would draw that on your own note, you can see that so the C stands for cosine, the A stands for all, S is sine, and T is tangent. And so in this quadrant down, or up here, if you think about it, both the x and the y values are positive, and so therefore all of the trigonometric ratios are positive in the 1st quadrant. In the 2nd quadrant, because the x's are negative but the y's are still positive, sine ratios are positive in the 2nd quadrant. That means that cosine and tangent ratios are going to be negative in the 2nd quadrant. In the 3rd quadrant, both x and y are negative, and so the only ratio that's going to be positive in the 3rd quadrant is tangent, which only looks at x and y. And finally, in the 4th quadrant, where y is negative but x is positive, cosine is going to be positive in that 4th quadrant. So if we now think back to that original problem that we looked at just 2 seconds ago, if I were to refine this question and say, okay, so when is cosine of theta equal to a half from negative from 0 degrees to 360 degrees, you have to consider, okay, so using the cast rule, cosine of theta is positive a half in both the fourth and the first quadrant. So that means that the related angle of 60 in both the first and fourth quadrant are going to give me a positive 1/2 ratio for cos of theta, which means that when I'm doing a 0 to 360 rotation, I have to consider that theta is going to equal 60, but it is also going to equal 300 degrees. So because of the repeating pattern, if we can look at this graph that we have here, where I just put the red dots is where theta is going to equal 60 and 300 degrees and give us a ratio for cos theta of 1/2, positive 1/2. So now the question is, let's solve cos of theta for negative 0.8667 from 0 to, so 0 is less than or equal to theta is less than or equal to 360 degrees. So let's think about the cast rule. Cosine is going to be positive in it's going to be negative in the second and third quadrants. And so we're only going to be looking for related angles in the second and third quadrant. Now, if you recall that root 3/2 is our 0.8667 ratio. So using the unit circle that we had from before, when root 3/2 is the related angle, is the x value, the related angle is 30. And so if the related angle is 30, that means that the actual angle of theta, remember that's the related angle, so that means that the actual angle is going to be 150 degrees. And it's also going to occur down here in the third quadrant as well as the second. And down in the third quadrant, the terminal angle is actually 210 degrees. So you have to remember that even though we're looking at the related angle to get our ratios, that it is the terminal angles that we are looking for, because that is how far you have gone around the unit circle to get to that related angle. So therefore, the cos of theta is going to be 150 degrees and 210 degrees, between 0 degrees being less than or equal to theta, which is less than or equal to 360 degrees. So now we're looking for when is sine of theta equal to 0.2345 between 0 and 360 degrees. So if we look at that, I hope that you're looking at that saying, wait a minute, I don't remember a unit circle that had 0.2345. So what we're going to do instead is we're just going to say, okay, so what is the inverse sine for 0.2345? Because we can still do that on our calculators. So when you pop that into your calculator, you're going to get that theta is equal to approximately 13.56, or it's equal to approximately 14 degrees. Now, if we keep it at the approximately 13.56, because if you actually then go back and say, okay, so what is the sine of 14 degrees? You're actually going to get 0.2419. And so I'm going to say that that's fairly far off of 0.2345. So in this case, we're going to leave it as 13.56 degrees. And so now we have to go back to the cast rule and say, all right, when are these sine values positive? Well, hopefully you can remember that they're positive in quadrant 1 and quadrant 2. So that means that the related angle in quadrant 1 and quadrant 2 will be 13.56 degrees. So of course, the nice easy thing about finding the related angle in quadrant 2 is we just have to say take 180 degrees and subtract the related angle to get our terminal angle. So therefore, we have two values of theta between 0 degrees and 360, and they're 13.56 degrees and 166.44 degrees. So here's one of our inverse trig functions. First thing we're going to do is simplify this equation and isolate cotangent theta. So once we have rearranged our formula, we get negative 2 cotangent theta equals 3, and then cotangent theta equals negative 3 over 2. Well, I don't know if you recall, but we can't do a cotangent theta on our calculator, but we can do a tangent. And so what we're going to do is we're going to take the inverse of cotangent theta to get the tan. So we get tan of theta is equal to negative 2 over 3. And then we're going to look at our cast rule and say, okay, when is tan negative? And tan is going to be negative in quadrant 4 and quadrant 2. So now we're going to look at this and say, all right, so what is negative 2 over 3? Well, it's, as you know, 0.6666666666. And so then we say, all right, that again, I don't identify that as one of my special triangles. So I'm just going to say, what is theta? What is the inverse tan of theta when it's negative 2 over 3? And when you pop that into your calculator, it's going to tell you that theta is negative 33.69. So our related angle is 33.69. And it's going to be in quadrant 4 and quadrant 2. And so our related angle in quadrant 2 is going to be 33.69, and our terminal angle is going to be 146.31. So now the related angle, the other related angle is going to be down in quadrant 4. So now we have to go all the way around to find out what my terminal degree is in quadrant 4. And in quadrant 4, my terminal angle is 326.31 degrees. So those are the two values for negative 2 cotangent theta minus 1 equals 2 between 0 and 360 degrees. So it helps to have a therefore statement, so therefore theta is equal to 146.31 and 326.31 degrees between 0 and 360 degrees. So I'm hoping that you're seeing that this is not actually that difficult. We just have to find out what the terminal angles are for a given trigonometric ratio. So there will now be a worksheet on Classroom for you to practice solving trigonometric equations.